Here we're going to look at question 32 from section 1 of the NSAA 2018 paper. So in this question we're told that we have some waves that are produced in deep water moving with a wavelength of 1.5 centimeters. Then we're told that these waves cross into some shallower water where their speed becomes c with subscript of s and they have a new wavelength of 1.2 centimeters. We're also told that these waves have a constant frequency of f, which is the same in both deeper and shallower water. The question then tells us that when the waves move into the shallower water, the speed is reduced by 18 centimeters per second, which we've noted here by delta c of being negative 18 centimeters per second. And then with this information, the question asks us to calculate the speed in the shallower water, cs. Now, if you'd like to have a go at this question yourself, then please pause the video now. Otherwise, let's have a go at it. Okay, so to go about answering this question, perhaps we should have a bit of a think about which equations we could use to help us solve it. So, we've been told some wavelengths. I've also been told we have a constant frequency f, and we're trying to find a speed. So there is an equation which relates these three, and that is that the speed of a wave is equal to its frequency multiplied by its wavelength. So since we've been given these three variables, it's probably going to be useful to try and use this equation. Now the first thing we could probably do with it is to consider it in our deeper and shallower water. Because we know that in the deeper water, we can substitute in our speed and wavelengths, denoted here. And for shallower water, we can sub in our new speeds and wavelengths here, with the same frequency for both, because we're told that it's a constant frequency and the frequency doesn't change between the two. So let's try and consider if these are actually going to be useful or not. Well, we're obviously trying to find the speed in shallower water. That's likely to be useful since this equation actually has the variable we're looking for in it. But what about some of the others? Well, we know that we have the two wavelengths in each of the depths of water. They've been given on a diagram, which I've also put over here, just to help us remember them. But what about CD, the speed in the deeper water? Well, here, while we don't explicitly know it, we know that the speed between the two changed by 18 centimeters per second. So what this means is that CD is just going to be equal to the speed in shallow water plus 18 centimeters per second. So actually, we do have an expression for this, which includes CS, the variable we're looking for. Now, while we don't have our two frequencies, they are the same, and between these two equations, we now have this one variable which is the same, so we could eliminate it anyway. If we did eliminate it, then we'd have two known values, and out of these two, the only unknown is CS. So CS is going to be the only unknown in our when we solve our two simultaneous equations. So how should we go about solving them? Well, there's a few different ways. I'm just going to do one way, which is to divide them. So if we do that, we divide the shallow equation by the deeper equation, then we get this, that the ratio between the two speeds is equal to the ratio between the wavelengths. Now we can rearrange this a little bit to get an expression for CS, but we have to remember that CD is equal to CS plus 18. So since we know lambda S and lambda D, all we have to do is rearrange this for CS, which is just going to take a few steps. So one of the things I've done here is just expand this brackets and then these brackets, and then bring all of our CS terms, the speed and shallow water terms, onto the left-hand side. At which point we can then divide through by this factor of 1 minus our ratio of lambdas for our expression for CS. So we know from before that lambda D is just 1.5 centimeters and lambda S is 1.2 centimeters. So we can substitute these in like this. And then since 1.2 divided by 1.5, our ratio of wavelengths is just 0.8, our speed in shallow water just becomes this expression here, which with some multiplication and a little bit of thinking about, we see becomes 14.4 divided by 0.2, which is just going to be the same. Dividing by 0.2 is just the same as multiplying by 5, so we know that this is going to give us a speed of 72 centimeters per second, taking care to notice the units. Since we've dealt in centimeters and 18 was in centimeters per second already. So this is just going to be our final answer, and it's going to correspond with answer E given in the question.